Here's another example for section 17.2. Two styrofoam balls of mass 10 grams are suspended by threads of length 25 centimeters. The balls are charged, after which they hang apart, each at an angle of 15 degrees to the vertical. Question A, are the signs of the charges the same or opposite? Well, since they're repelling each other, we would say that the signs are the same. B, are the magnitudes of the charges necessarily the same? The answer to this is no. We saw in an earlier problem that the force between the two balls would be equal even if the charges are not. Again, that's Newton's third law. C, find the net charge on each ball, assuming that the charges are equal. Okay, I'm going to sketch this and then solve it. So I'm going to start by drawing in a vertical line, because they tell us that each ball is at an angle of 15 degrees to the vertical. And there are 3 forces on each ball. There's a force of gravity. There's an electric force. That's the repelling force. And then there's a tension force. We should be able to take those 3 forces and draw a right triangle. Okay, so now we're going to try to solve this. They've told us that the force, or that the mass rather, is 10 grams. So the force of gravity must be the mass times 9.81. That's 0.010 kilograms times 9.81. And what else do we know? We know that the angle is 15 degrees here. So the magnitude of FE is our horizontal component, and FG is our vertical component. So I know that the tangent of 15 degrees equals opposite over adjacent. That would be FE over FG. So I know that the tangent of 15 degrees is equal to FE over 0.010 times 9.81. And when I solve that for the electric force, I get 0.0262 newtons. Okay, now I've got the electric force, and what I want is the charge. In order to solve for the charge, I'm going to need a distance. I know that the length of this string is 25 centimeters, so I can use trigonometry again to get the distance between the strings. I know that the sine of 15 is going to equal this distance over 25. So that distance is going to be 0.065, which means the entire distance, this entire distance between the two objects, is going to be equal to 0.13. Okay, so now I think I'm ready to solve. I've got Coulomb's law that says the force between the two charges equals kq over r squared. And in this case, the charges, it says I can assume that the charges are the same. So that's kq squared over r squared. So now I'm going to make some substitutions. Instead of writing F, I'm going to write 0.0262 newtons from above. K is 9 times 10 to the 9th. Q squared is unknown. And then my distance between the two objects was 0.13. So now I would solve this for the charge. And when I solve for the charge, I end up with 2.22 times 10 to the negative 7th coulombs. That's my charge. Finally, question D asks, what would happen if the balls were uncharged? Well, they would just hang straight down. They would not repel. And there you have it.